Previous video on trigonometry covered right angled triangles and the tangent ratio. We labelled the sides H for hypotenuse, O for the side directly opposite the angle we're dealing with, and the remaining side here, which is next to the angle, that's adjacent to the angle, is labelled A. So that's how we labelled the triangles. We looked at the tangent ratio, which was opposite over adjacent. So the opposite over adjacent ratio is called the tangent ratio. So that's the length of side O over the length of side A. There are three different kinds of question. Finding the unknown angle given the ratio. What you did was inverse tangent the ratio, and it will tell you the angle. Second case was where you're told the angle and you're finding a side. If it's the opposite side you're trying to find, then you get the tangent of the angle, which tells you the ratio, and then you solve the equation to get the opposite side. Third case was if you're trying to find the adjacent side. So you're told the angle, you have to find the adjacent side, you tangent the angle to find out the value of the ratio, and you solve the equation to get the A in the bottom, the adjacent. So three kinds of example. Here they were from the last video. Find the angle, label the sides. H is opposite the right angle, O is directly opposite the angle that you're dealing with, A degrees here, and the adjacent's just next to the angle. This involves O and A. That's the tangent ratio. Tangents opposite over adjacent. So tangent of A is 2 over 3. The tangent of the angle is 2/3. To get rid of this tan here, in the calculator you inverse tan. So you press the button marked inverse tan. You inverse tan the ratio 2/3. Up comes the answer. You write it down and then you round it as appropriate. 4 lines of working. This was the tangent function, opposite over adjacent. Find the angle, inverse tan. Second case was find a side. Again, you label the sides of the triangle. We're dealing with O and A. Tangent of the angle 33.7 is opposite over adjacent, A over 3. So there's a tangent's opposite over adjacent. There's tan 33.7, it's the opposite side, A over 3. Don't mix it up with the capital A, which is just to label the sides. Now the numbers in the bottom, you're dividing A by 3, so to get rid of that 3 you would multiply the right hand side by 3, and to balance it multiply the left hand side by 3, and it will give you that. If you think about it as simply 3 coming up to multiply the function here, it's a bit easier. Put that in the calculator, write the unrounded answer and round it off. 4 lines of working. So that's find the letter with the letter in the top of the fraction. Take the bottom number of the fraction up to multiply the other side. And the final third case was after labelling the sides, identifying its tangent. Tan 33.7 is opposite 2 over adjacent A. This time the letter's in the bottom, a bit more awkward to solve. So, as in physics, where you turn around formula using a little triangle like this, here this says tan 33.7 is 2 in the top, A in the bottom. 2 in the top here, A in the bottom. Turn the formula around to find out A. A is 2 over tan 33.7. There it is. Or simply memorise this. If the letter's in the bottom of the fraction, swap it with the function. So 2 divided by tan 33.7 in the calculator gives you this long answer that you write down and you round it. 4 lines of working. So 4 cases. The letter is the angle, you inverse tan. The letter's in the top line of the fraction, you take the bottom number up to multiply. And here the harder case, the letter's on the bottom, it swaps with the function. Same 3 kinds of questions apply to the other trig ratios. So just like tangents opposite over adjacent, the ratio that's adjacent over hypotenuse is called the cosine ratio, written here as cos, and the ratio opposite over hypotenuse is called the sine ratio, written here as sin. So it's sine, cosine and tangent, sin, cos and tan. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. This is the memory aid, SOHCAHTOA. So that's to remember sines opposite over hypotenuse, cosines adjacent over hypotenuse, and tangents opposite over adjacent. So when we do a question, you've got to figure out, is it sine, cos or tan? You get that by labelling the sides. And then you've got three kinds of question. You're trying to get the angle, the top line of the ratio, or the bottom line of the ratio. Three different cases. Here's an example. Find the angle A, label the sides. H is opposite of 90 degrees. O is directly opposite the angle. It's at 6. The adjacent is blank. So we're going to use O and H here, the 6 and the 7. So we're using O and H. Think of SOHCAHTOA. What uses O and H? So does. It means sines opposite over hypotenuse. First line of working you'll get marks for in an exam is writing sine A is 6 over 7 opposite over hypotenuse. Trying to find the angle, want rid of sin here, inverse sine it. So inverse sine 6/7 in the calculator, write the answer down and round it. 4 lines of working. Try to find the angle, inverse function. Here's another example. Label the sides. H is opposite the right angle, looking out from the angle on the opposite blank side here, O. The adjacent's next to the angle, it's the 7, so we're using A and H. What uses A and H in SOHCAHTOA? The K bit, cosine adjacent over hypotenuse. So right, cosine of A is adjacent 7 over hypotenuse 9. To get rid of that cos, you inverse cos. So you inverse cos 7/9, answer off the calculator and round it. Same 4 lines of working as before, it's just a different function. Just picking out whether it's sine, cos or tan first, get the ratio right, and then this is first case, find the angle by inverse function. Find a side. Opposite the right angle is H, opposite the angle 60 degrees here is O. The side next to the angle A is blank, so we're using O and H here, D and 7. So using O and H in SOHCAHTOA, that's the SO bit, sines opposite over hypotenuse. First line of working, it's really important to get right. Sine 60 is opposite D over hypotenuse 7. On the right hand side we've divided D by 7, so we want to get rid of that by multiplying the right by 7, and so we multiply the left by 7 to balance it. Basically the 7 comes up to multiply the sine 60. Put that in the calculator and round it. 4 lines of working, the letters on the top. Now, we're going to use the same triangle. So that's why that's 1A, it's 1B that will follow, which is, in this case, we're going to label the sides as before, identify using sine as before, and write the ratio. Sine 60 is opposite 6 over hypotenuse D, so the letters are on the bottom. We're awkward case. D has to come up to the top here, and the sine 60 go down to the bottom, the swap over. D is 6 divided by sine 60 on the calculator, unrounded answer, and it rounds to 6.9. So 4 lines of working, the letters on the bottom, swap for the trig function. So that's the 3 cases. Angle to be found, letters on the top of the fraction or the bottom of the fraction. Here's a second example for the sides. Hypotenuse opposite the right angle. Opposite the 27, O, it's a blank side. The adjacent is the letter D, that's the one next to the angle. Using A and H, K in SOHCAHTOA. K is adjacent over hypotenuse. Cos 27 is adjacent D over hypotenuse 9. That's fine, the letter's on the top. The 9 just comes up to multiply the cos 27. Answer off the calculator and round it. 4 lines of working, happens to be the cosine in this case. Similar triangle going to be used in the next one, which is simply this time doing exactly the same as before, labelling the sides. identify its cosine. There's the ratio. First line of working, cos 27 is adjacent 8 over hypotenuse d. Letter on the bottom, swap with the trig function. 8 divided by cos 27 in the calculator and round it off. 4 lines of working. So sine, cosine or tangent, there's 3 different kinds of question where the letter could be the angle, or on the top line, or the bottom line. This is a worksheet. Find the angles. This is the first half of it. You can download the worksheet using the link in the description and it'll have the answers with it, or you can pause the video. Here's the second half of that worksheet. Again, you can pause the video, download the worksheet. So this is all find the angles. Here are the answers. That's the first half. So pause the video to check the answers or use the worksheet. Here's the second half answers. Here's a second worksheet where it's find the sides, mixture of sine, cos and tan, and sometimes the letter can be in the top, sometimes it can be in the bottom. So this is the first half of the worksheet. Pause the video, download the worksheet with the answers. This is the easier set of questions. Here's the second half. Another set of questions, but they're more difficult because this is the cases where the letters on the bottom line of the fraction. Again, pause the video or download the worksheet. And here are the answers. Here's the answers to the second part of that worksheet. Now we're going to look at applications. Excuse me. So this is a cliff 80 metres tall. There are 2 ships looking up at the top of the cliff from a 40-degree angle for this second ship, a 60-degree angle for this first ship. To find the distance between the ships, so I'm going to apply trigonometry here. It involves angles and sides of triangles, because if you look at a big triangle, 80 metres tall, out to the second ship with this 40-degree angle, this distance x is the distance from the ship to the bottom of the cliff. If we work out that distance and do it for the second ship, working out its distance from the bottom of the cliff, we can work out the distance between the 2 ships. So there's the second triangle. 80 metre cliff, 60-degree angle, distance from the bottom of the cliff, y. The difference between x and y is the distance between the 2 ships. So here are the 2 triangles. Now rather than use the 60 degrees, I've made the triangle up to 180 degrees to get that 30, because it's easier to use the 30, as you'll see in a second. There's the hypotenuse, there's the opposite to the angle, the y, and there's the adjacent. So we're using opposite and adjacent, that's tangent. Now by using the 30 degrees. The tan 30 is y opposite over 80, the adjacent. The letters on the top. If I'd used the 60 degrees, the letters would have been in the bottom. That's a bit more difficult. So 80 in the bottom, take the 80 up to multiply the tan 30, and there's the answer, don't round it. So tangent function on a right angled triangle, working out this distance of the first ship from the base of the cliff. Apply the same to the second triangle, and tan 50 is x over 80. Take the 80 up to multiply, get the answer off the calculator and don't round it. That's the distance of the second ship from the base of the cliff. The difference between x and y is how far apart the ships are. Unrounded answers are subtracted. You've got this unrounded answer and it's rounded off to approximately 49.2 metres. So the ships are 49.2 metres apart. Now there is a worksheet involving this, so you can download it using the link in the description. So this other worksheet has a mixture of trigonometry questions, finding missing sides, missing angles, mixture of sine, cos and tan, figuring out the missing side when the letter's in the top of the fraction or when it's in the bottom of the fraction. And it's got some in context using trigonometry, and it's got the answers at the end. So that's a worksheet on trigonometry. The previous worksheets there with the answers, and that worksheet with the answers. So you'll get plenty of practice. There's also to be downloaded a set of notes. So just a couple of pages that summarises the two videos on trigonometry with the right angled triangles. Hope you found the videos useful. Thank you.